So this session's only half hour. We'll do questions whenever anyone wants, so please just feel to jump in. The idea is we're going to go through basic introductions. What is cost? Why'd you do it? You know, what publications are available to you to start off with. We'll go through find some small detail in submissions, and then we'll go through how to structure cost of bill of materials. So to start with, my name's Ollie. I was a competitor a few years ago. We won the cost event twice, came second once. Bath Electric I saw earlier. You beat us by 1 point. I still haven't forgiven you. But it was great. So former student background, now in motorsport and project management. I raced Le Mans this year, which was great. So kind of everything happened because of former students. So the people you meet along this journey will take you through into your careers. It's A, it's an amazing opportunity, and B, you meet some awesome people. So it's a little bit about me. So right, what we're going to go through is what is cost, and pretty much why do I care, resources available to you, submissions for this year, and then how to structure it. And please feel free to ask questions at any point. It's absolutely fine. So what is cost and why do I care? So everyone knows cost is the one that's loads of admin, you've got to do all the research, there's loads of quotes you've got to find, you've got to cost every part of your vehicle if you're class 1. What is it now? Former student class. And the really reason is, why is that so important? So having a really good understanding of cost and manufacturing can only make you a better engineer or a better project manager or whatever you want to go into when you graduate. So my favourite line is, you can have the best design in the world. It can solve every problem, but if you can't afford it, it's useless. If you can't make a business case stack up, what's the point? So it's not all about design, it's not all about business. You have the best marketing strategy. If you still can't cost it, there's literally no point having it. So the reason you are here is because you have to go up against that lot, which is the best picture I could find online. There's some other ones I found which are great, but you have to go up against these guys. So people you see there are industry experts, from John, who's managing massive accounts for big companies, to people that run charities, people that, you know, F1, people that have done all sorts of racing, MOD, anything you can think of, these guys have done. Any excuse you can think of, they've used. Any lie you can create, they'll find. So make sure you're just truthful in what you're saying. These guys have been there, they've done it. A lot of them have sat where you're sitting now, so the dog ate my homework is not going to work. So the idea is, you have to convince them that you know not only what you're talking about, but you've truly understood and researched what it is to cost something and the manufacturing process. So you guys being in a lab at 3 o'clock in the morning doesn't look great on a cost of bill of materials. What would it actually cost? Have you considered OPEX, CAPEX? Have you considered hourly rates? These guys know it. They will ask you. If you crumble, they'll know. So first thing, and most importantly, there is loads of things out on YouTube that John and I, and in fact everyone has done over the last few years to make sure that you guys are set up for this. So watch the videos. If you don't watch the videos, I'm likely to be thinking about what's for lunch. Because if you haven't looked at the submissions, we've looked at the presentations, the publications we've written, and I ask you a question that's in there, I'm not listening to what you're saying anymore. I've zoned out. I'm wondering what's for lunch. Is the bar open after this? So make sure, if it's on YouTube, if it's on the IMechE website, read it, watch it, absorb it, ask questions on it. Come on guys, come on through. Question us on what we've written. If it's wrong, tell us. Oh guys, come on in, it's fine. Yeah, just stand at the back somewhere, I think. You're late, that's it. No, of course. Absolutely not a problem. While we're on that subject, don't be late with submissions. Turn up late to workshops, it's fine. Don't be late with submissions. I think John's threat last year is, if you submitted the cost tool late, he was going to crash the website and you wouldn't be able to do it. So make sure, take 2 weeks off what we say the submission is, submit it then. That's your deadline. If anything goes wrong, you've got an extra week. Do not do it on the last day. You will get shot. So let's move on to the submissions themselves. Former student class, and again, John and Lee will go into these more in detail when you have the one-to-one sessions. We can talk about them and how to structure them. But first, let's go former student class first. Detailed bill of materials. So I don't know, by show of hands, who has done a cost report before? Okay, show of hands with who has no idea what I'm talking about. Yeah, so I reckon there's still a few of you. All right, okay. So a detailed bill of materials is tell me how you're manufacturing this. So there's a really good trick, and I used it when I was competing in this. It's pick and assembly. So throughout the year, I want you to pick small things. Pick a toothbrush, pick something small. Manufacturing processes aren't particularly difficult, and tell me everything that's in it, so material, everything used to manufacture it, any tooling, anything like that. But picture it as you're walking into the university. Start small, because if you look at a car, a bill of materials for a car is huge. It's thousands and thousands and thousands of parts. Start small. Use a pen. If you've got a pen in your hand or a notebook in your hand, go, right, okay, how did they manufacture that? What was the processes that went into it? And just get bigger and bigger and bigger and bigger, and then eventually you'll be able to look at your car and go, right, wheel assembly, right, that's that, right, nuts and bolts on that, okay, we're going to need Loctite on that bit, we're going to need that. And you'll picture it and you can see it. You know how you have an exploded view in CAD drawings or actually on technical drawings? You need to be able to do that in your head. Work out every part that's in it, every manufacturing processes, every material. It makes writing the bill of materials easy because you can see it. There's other tricks in Former Student if people have got one-to-one sessions, I'll talk you through them later on. But for cost, picture what it is you're doing. Pick inanimate objects. If you're going out for a beer, use a pint glass. If you're going out for whatever, pick anything as you walk through the street. It's such a powerful tool to go, right, okay, I know how that's manufactured because I've seen it. And if you look at something, you go, I have absolutely no idea how they manufactured that. Research it, have a look into it. It'll only make you better at this, especially when they start looking at special conditions. You get into cost finals, they like to throw curveballs. It's okay, they'll show you a steering wheel, proper steering wheel, you know, horn and all. How'd you manufacture that? Well, you wouldn't have done that as part of Former Student because your steering wheel's likely has no functionality whatsoever, it just turns the wheel. But how would you manufacture it? If you've gone through this process of being able to think through bill of materials in your head, you'll get it. Most of manufacturing is broken down into a bill of materials and a routing. Bill of materials, what goes into it, routing, how it's made. So what you have is a top level, which is the computer, and then next level down, and you have tier 2, tier 3, tier 4, tier 5, back all the way down to raw materials. So try and think of it as what's in it, how is it made, what does that bit make? That bit feeds into something else, feeds into something else, feeds into something else. Again, I keep rapping on about it because it's such a powerful tool when people throw curveballs. If you get really good at it, start going, okay, how would you scale it? How would you change the manufacturing process? You know, for a toothbrush, likely is you're not going to because they're made in the hundreds of millions. But if it's something that's a one-off, what would I change? What materials would I use? How would I change the manufacturing process? I can't tell you enough, especially from an industry perspective as well. I do it now, I sit and write quotes for Formula 1 teams or Le Mans teams, and you write a quote of, they need a new fender, they need new bodywork. Most of it you do in your head, and it's so easy to type it up because you've already worked out what that system is. This will come into your D-bomb and C-bomb. So a detailed bill of materials, oh sorry, we didn't do the other bit, apologies. Concept class is slightly different. So you don't have to do a detailed bill of materials, you do a costed bill of materials, which is basically where you take into account time and cost. But we're going to go on to that later on. There's very little difference between the two cost bill of materials for FS and concept class. It's all in the submissions. There'll be extra things posted out later on down the line. Supporting material, and we're going to go further into supporting material later on as we go through these. Please, you will get negative points. John will kill you if you do not submit it as one A4 PDF document. You do not want to be on the wrong side of John Dangerfield. I'm joking, it's fine. But there are negative connotations for doing it. There's teams that go and structure it all out lovely, so chassis tubes, and put a whole file system together. Don't. The idea is it's one A4 document, PDF, A4, all the way through. It's our job to scroll through it and go through everything there. So anyway, we'll jump further into the detail in each one. So detailed and costed. What you can see in the bit up here is a costed bill of materials because it takes into account cost and it takes into account time. This is a really cool trick for prepping for an event. You might not necessarily bring this to the event, but the idea of being able to make sure that you know what's in them. So what I did was, I need to know exactly how much time or tack time it takes me to build one vehicle. If I know how to make it build one vehicle, I can then scale that, which is really handy when you need to do the business event because you've got that information, you plug it in. So it's got time, based everything on hourly rates, and then you've got costs based on my hourly rate against the time. But obviously there are massive considerations to be made in hourly rates. Okay, let's come through. You need to take into account, right, I've got a welder. He's a good welder, qualified up, he's all good, but I need to take into account what goes into his hourly rate. How much am I going to pay him? National insurance, I'm going to pay pensions. All of that needs to go into what your hourly rate is, and you need to be able to explain that. When I go, how did you calculate your hourly rate? I'm not going to give you any prompts, you need to tell me. We'll go further into that when we go through into explanation files. But basically, a detailed bill of materials breaks up into 4 sections: materials, tooling, process, fastener. I haven't got to tell you what those are, but there's a brief description there of what they are. A costed bill of materials takes into account time and cost. Material-wise, get a quote. It's not difficult. Go for one part, go for 1 million of those units, get a decent cost range. Go, if it's going to cost me £3 if I buy one, it's going to cost me 50p if I buy 1 million of them. So make sure you've got that range for scalability. When you're looking at tooling, chassis are a big one. The amount of teams that go, oh yeah, we'll just weld it up. Oh right, did you? You had no tooling. Or composite one. Okay, did you do pattern mold? Did you straight off the pattern? How many parts can you get off that pattern? Oh no, we just laid it up. Oh, you laid it up over nothing. Right, okay. You didn't, but all right. Make sure you've got every piece of tooling you use. If you're doing any composites part, 3D printed jigs. If you're putting trim lines on it, or if you're putting drill holes, anything like that, put it in there. It shows that you understand your manufacturing process. It shows that we understand that you have an understanding of your bill of materials as well, because it's going to be a cost. Even if it's a consumable, it will be a cost. You're doing composites, you're going to wear gloves. Okay, you're going to use dabbers, you're going to use everything else. Make sure it's in there. And processes are, and we'll go through an example more in depth in a minute. How did you get from that piece of steel to that upright, or whatever it is you're manufacturing? Fasteners, nuts, bolts, washers, make sure everything's in there. A cable tie needs to be costed. Please make sure you've costed your cable ties, because I will check. Lastly, again, how long does it take? There are hundreds and hundreds of different ways to work out how much time you've used. You can do it as a direct cost. You can take it into account an absorption rate. You can do indirects. You can do whatever you want. It is your job to go and have a look at different ways to cost model. If you go and talk to some of the guys, so Lee Wall works for Ford, big OEM company, they will have a different way to myself. I work at Retrack Group, we make Formula 1 parts. Very, very different. So ask around, talk to other people, friends and family, find out how they cost model different things. And then costs, again, is in a relationship between those two. So we spoke briefly about supporting material. Please make sure it is one A4 PDF, especially for concept class. For formal student class, absolutely you have to have it. It means we can check the detail in your BOM. Okay, right, okay, well you said that was the tolerance. Okay, well you've machined it to that. You didn't machine it for that price. So make sure it is correct. But concept class, we don't see your vehicle. When you submit it, we see hopefully a nice rendered image on front of your costed bill of materials. But other than that, we've never seen your car before. We won't see it at the event, we won't see anything. This is the first time we get to see parts of your vehicle. So if we do chassis and powertrain, which I think are going to be the things for this year, we will see, okay, right, they're looking this way, right, what manufacturing techniques are they likely to use? Or my favourite is when you get a drawing and a cost model and you go, well, you can't make that like that. So it's questions that we can bring up to you guys as well. So make sure it's submitted. It sounds silly, but it's a massive thing. Explanation file. Your explanation file is the most important document in cost, because it's all of your combined research in one. Most people go, it's the costed bill of materials and the detailed bill of materials, but if you have the understanding, it's here. If we've got one-to-one sessions booked, I'm happy to show you examples of these as well. But hourly rates, are they direct, are they indirect? You guys in the room, when you move into careers, are very unlikely to be direct costs. You will all be indirect. You're going to be engineers and procurement and project managers and program engineers and all that side of it. You will be an indirect. Make sure you have an understanding of what is a direct cost and what is an indirect cost, especially if you start looking at absorption rates and trying to match absorption rates and trying to reduce what your company's earnings. Staffing. So you are going to have some direct costs. You're going to need welders, fabricators, laminators, trimmers, anything else. What do you need? Could you have a trainee and they cost £12 an hour? Or do you need a composites laminator that's been doing it for 50 years, it's going to make your chassis, and actually he's probably £25 to £30 an hour? That's going to make a massive difference when you start multiplying up time, especially when you start looking at making more of your vehicle. Capacity planning. One of the other judges, John, will ask you how many hours are there in a year? How many are you utilising? Make sure you know it. Make sure you take into account holiday, sick, bank holidays, weekends, if your presentation works. make sure you take that all into account, because you have a set amount of hours in a year. You have to optimize those. I know in this room, all of you are well aware of the time constraints you have to build a vehicle. It's the same in industry. Make sure you understand. Just give us a figure. It's around 1,600, but make sure you have an explanation for that. So time calculations. If you are going to run a machine, you're going to use G-code on a CNC machine. You know what your cycle time is, right? Add it in there. You know exactly what it is. But you've also got, if you're going for OEM stuff, you're going to clock on and off a job. You're going to clock on and off, that's 30 seconds, 40 seconds. Times that by 1,000,000, that's a lot of time. Break it down into really critical steps and make sure you can tell me what they are. So as I said earlier, most things are broken down into bill of materials and routing. This is where your routings come into effect. If you're going to kit cut, look, it's unlikely you're all on a Zund kit cutting for composites, but if you're going to hand trim them, tell me how long that took. I need to know that it's been kit cut, it's been laminated, has it got a debulk, what is it, how does it look? Break it down into real small bits. This is where it gets interesting, and anyone that wants to go out of side of engineering, more business side of project management, this is where it gets interesting. CapEx and OpEx, so capital expenditure and operational expenditure. This is where cost of sales over revenue, and then capital expenditure really is, what do I need to get this project done? Do I need to invest in tooling? Do I need to invest in machinery? Have that understanding. So when I go, okay, you've machined your uprights on a 5-axis GMU or whatever it is, cool, how much does that cost? And how are you going to, use that as an annuity? How much did that cost you? How much are you going to resell it for? Have that business understanding. It will come in handy for other events, and it will come in handy when you come out of this. But operational expenditure is your cost of sales. So you've got to keep the heating on because it's cold, and it's really expensive to heat anything at the moment. So have that understanding. So you've got to have lights, heating, your direct cost, pension scheme, anything you can think of that goes into a cost, put it in there. Have a really, really good understanding of operational expenditure. Are you within your company model that you're costing for? Does every person that's an indirect have a company phone? Well, how much does that cost? It needs to be really in depth. And again, when we do one-to-one sessions, we're more than happy to discuss those as we go further on. Budget planning. You all have a budget. Some will be hundreds of thousands, some will be a couple £100. I started and I paid for the team to start off with. And then we got sponsorship and it all went up and it was great. But we need to know what your budget is. It doesn't matter what it is. It doesn't matter what you're trying to achieve with it. Tell us. Tell us how you controlled the budget. Tell us where you got it from. If it's all sponsorship, it's all sponsorship. That's cool. If the university pays for it, oh, great. If you and Dave are going to work behind a bar for 3 nights a week to try and make the money to do it, cool, tell us. So what is your budget and what did you need? What was your benchmarking? There's a workshop after this with Jack Burton about benchmarking. I really suggest you go, it's really good. And it's all about what are you setting out to achieve? How did you do? And what did you, retrospectively, how did it go wrong? Did you spend more money? Did you get more money in? Did you get a surprise sponsor that paid for everything for you? Great. Tell us how you managed it. So, again, cost tools as well, talking about managing budgets. Show us what your budgeting is. Every week, do a budget schedule. Oh, we spent this. Oh, that's a bit late, so we're going to cash flow back again. It is essentially a cash flow forecast. Show us what you're doing. Procurement. Procurement's always something that no one ever does. Show us your procurement planning. How did you plan your procurement? Does your university have to buy everything? Have you got a company card that you can just, yep, done, lovely. Have you got to submit requisitions to purchasing, they buy it? Show us. It shows that you've got a good understanding of purchasing. It's a really useful tool, especially when you go later on, does your team have a limit? Can you spend £1,000? Does a team leader have 5,000? Tell us, show us. It shows you have an understanding. Contingency. It will go wrong. 100%. No one's going to have a perfect year. Tell us what you did when it went wrong. Show us. Do you know what? We crashed the tool into the upright. We killed it. It's £1,000 gone. We're £1,000 short. Right, how did you cover it? How did you get around it? Did your mate in the garage sort it out for you? Show us. Tell us. It shows that you've got an appreciation for it. Buzzword, bingo, sustainability. What are you using and why? Are you planting trees? Are you full greenwashing? Screw it. Screw the planet. Yeah, it's lovely. It's green. It's wonderful. Or are you actually looking into it? Are you looking into flax? Are you looking into jute? Are you looking into hemp? What are you doing? And let's find out. Talk about it. If you're not doing it and you're going to go, we're just going to go out to win everything and we're going to have composites everything and screw the planet. It's light, so it's green. It's good. Tell us. All right. Don't hide it. Don't do it, but don't hide it. You will get asked. Again, we talked about CapEx earlier, we talked about manufacturing requirements. Are you going to be doing all of it in-house? Are you going to subcon it? What's your subcon process look like? Have you got goods in, goods out? Have you got an inspection off each side of that? Show us, tell us. They're really important steps. Again, waffling on, there is loads to consider. I had a look at my old one last night. It's probably 25% of the way there. I mean, it won it twice, but it was 25% of the way there. From how I look at it now, it should have been 500 pages. Please don't write 500 pages. I don't want to read 500 pages. There is a good limit. You know, it can't be 1 page, and I don't want 500. There is somewhere nice in the middle. Capturing cost, we've spoken about as well, and quality assurance. What's the cost of quality? You're going to make a chassis. The likelihood is you won't scrap anything because it'll be fine. Don't worry about it. All right. But when you go further on, there is a cost to quality. Is it rework? There's a cost for that. So not only, there was a saying once, we haven't got time to make it right, but we've got time to make it twice, which absolutely isn't right. Spend the time, do it right, don't make it twice. So the idea is have an understanding. Did you have to do any rework? It's a really good idea and a hint to all of you. Put rework cost in your costed bill of materials because it shows you've gone, I made a mistake, so contingency planning, and then you've gone, okay, how am I going to rectify that? I'm going to put rework in. Okay, it's a really nice one and it's a nice piece of detail for judges to see. It's something that I would pick up on. Okay, so we've just spoke about that there's loads of introductions. This will be available, I think, on the iMonkey website, so please go through. All of these are additionally available. There's loads more, so please have a look at them. But what we're going to do is go on to, I believe that one, and have a look at how you structure things. I was talking earlier about being able to do bill of materials in your head. I wrote this 2 years ago when there was nothing else to do in lockdown. So the idea is, this is how I vision it. You can do it any other way. People do it top up, bottom down. There's loads of different ways, to sideways, to whatever you want. This is the way I see it, and please feel free to change it however you want. So I need to build an impact attenuator. So I've got a drawing. Let's assume this is built to print. You're the manufacturing team and the cost team. Someone from a design team has given you a drawing. You go, oh, great, here we go. So I need an impact attenuator assembly. I've made it really simple. It's going to be steel tubes. It's an alley plate holding the actual impact when you're on, and I've got an anti-intrusion plate. Really simple assembly, 5 parts. So okay, so I need that. So what do I need? I've got an assembly for the impact attenuator, the foam, great. I've got a backing plate to hold it on. Yeah, that makes sense. And I've got an anti-intrusion plate. Bolt those on. Lovely. That's my part there. So next scale down. Right, what are those assemblies made of? Okay, so I need a high density foam. Yeah, that makes sense. And I need a 1mm plate, stick to the back of it. Right, okay, well, I've not got any adhesive there. Right, okay, I've got it. 2mm steel for the anti-intrusion plate. I think that states it in the rules, so let's just make sure that's correct. Okay. Well, that's not quite the full process, so let's carry on. Well, how am I going to bolt this to the actual car and hold it together? I need some nuts, I need some bolts, and some washers. Oh yeah, but that doesn't stick. Oh, some contact adhesive. 9323, especially composites. Brooks is here, normally composites. 9323 is your best friend. All right, so right, I've got fasteners. Well, that makes sense. So what's next? Let's go through the next stage. So we've got the rest of it here. So next bit is I actually have to assemble it together. So that is a process of me actually putting it together. Well, I've got my fasteners, so that makes sense. At this point it gets a bit complicated, so there's a bit of a key. Let's move further down. Right, okay, so I've got other processes here. So I can't just put it on and put the contact adhesive bottle in it, doesn't work. So I actually have to put it on. Well, there's time to that. It's a 2-part adhesive. It's a 9323, it's 2-part, I've got to mix it together. Okay, well, how long does it take to go off as well? So question for everyone, do you cost drying time for adhesives? Because you can't do anything else with it while it's curing, but it's a question to ask, I try and ask it every year, why is that not costed? Or why did you cost it? And for you guys to answer. So we look into more and more processes. So if we go from the bottom on this one, makes it slightly easier. Okay, so I've had my goods in. I've got my 2mm sheet, great. Right, I'm going to go and give it to this guy. So I've issued that material. There's a cost from me picking it up in stores or wherever your goods in department is and giving it to the guy that's going to machine it for me. There you go, right, lovely, you've got it. Next bit is I've got to set up the machine. Am I going to laser cut it? Am I going to water jet cut it? Am I going to do it with a bandsaw? Am I going to try and cut it by hand? Tin snips aren't going to work. Okay, so what am I going to do? So there's a process there. Again, set up machine breaks into about 8 different processes. It's just not as easy as just go, there you go, done. Okay, so just be aware that these are very broad terms. So apparently we're going to cure plate instead of cut plate, apparently. we'll carry on. Cut plate to shape. Okay, so again, what was the manufacturing process? Did you program the machine? Every part of this needs to be thought about. This could be 50 steps to do it one by one by one. And again, if you're making one part, probably not likely. That doesn't really matter. Do it in 5 steps. If you're going to make 1 million of these, every second matters, because you're costing everything to 4 decimal places, and when you times that by 1 million, that's a lot of money. That's a lot of revenue to lose. So again, we cut the plate, we're going to deburr it, and there you go. That's the part. Cool, got it. So what do we do next? And it's always, what's the next step? What was the step before? What was the next step? So that's kind of where it tries to take you, but there is a full process when you start taking into account tooling. So what tooling is required at every point? Is it, I need a screwdriver? Well, that's technically part of tooling, turn of a screwdriver. You could go into that much detail. It could be, I need a jig to locate it all and have it all correct. That's entirely up to you, depending on the system, but make sure you've taken into account material, fasteners, tooling, process. Those are the four detailed bill of materials. Then consider time, then consider cost. But these are all available online, so don't worry about taking notes or anything silly. But you can see how a 3-part assembly, I didn't move, I didn't touch it. There we go. 3-part assembly turns into quite a marginally complicated assembly. When you start looking at chassis, how much more complicated is that? That's every weld. Did you wire brush each tube? Did you acetone it? What did you do? What did you get to the end of that? So this carries on, but we can go into the actual bill of materials itself. So have you guys got access to the cost tool yet, or does that happen after this event? I can't quite remember. I'm going to assume by the blank faces, none of you have got this yet. Cool. All right, so this is what the cost of bill of materials looks like when you log in, when you go into your student account. So your faculty advisors and team leaders will have access to this eventually, and then they can allocate who has access. So that's what it looks like. The nice bit now is you can do snapshots. It used to be that you only had one, and if you messed it up, that was it. You had to start all again, and it was a nightmare to move anything about, and you could obviously export it. So now if you wanted to, you could do snapshots of full system, give chassis to the chassis person, give suspension to the suspension person. I wouldn't suggest breaking it up too much because you'll have different cost models across the vehicle. You need someone to run it. And normally my suggestion is team leaders need to be all over this. So anyway, that's what you'll get. That's the introduction page. That is the most daunting page you have. You know when you go onto Word and you're trying to write an essay and it's just the blanking thing? Yeah, this is worse because you have to cost a whole vehicle on this and you start with nothing. So make sure you've thought about it. Whiteboards are your best friend with this. Sketch it out with a team before you just start throwing things in, because you'll get 700 lines in and go, oh, that doesn't make any sense because that should be there and this should be there, and you can't move them. You can move assemblies, you can't move processes and parts. So make sure you've sketched out a good plan before you go into this. And it really is a case of, you know, new part. Very unprofessional. Sorry. Part name. What system's it in? Breakdown in there it's pretty comprehensive. It's pretty good. You can add other if there are things on your vehicle that aren't there. Assembly type. This is massive. The make or buy. We were talking about in-house or subcon, etc. earlier on. So make sure you understand. Have you bought this in, and where does subcon sit? Because you made it, but you didn't. So is it you bought it from a supplier? Even if you've worked with the sponsor, how, you know, think about how that works. Comments, please put comments on things, because you might just put upright, but if you put no comments, well, I don't know what that is. Drawing numbers are always a good idea. If you've marked your drawings with drawing numbers, use them, because it means we can look through support material and go, okay, right, they said it's whatever notation you want to use, please put it in there, and obviously quantity. Nice and simple on that one. That's kind of how it ends up looking. So we looked earlier and there was 3 parts to the assemblies. That's what it looks like. You've got your top level, which you can see here. So frame and body, where impact attenuator sits. Underneath that, you've got impact attenuator as your assembly. Underneath that, you've got the actual full assembly itself, and then the 3 parts that go into it. So what you'll end up doing is putting material, process, fastener, material, process, fastener, material, process on each one. Okay, so when you go into each assembly, you've got process, material, fastener, and tooling. Okay, granted, I think I may have taken the screenshot at the wrong time, so it's not normally edit, it's new. But again, add what the material is. So it's a material out of those 4. What material is it? There is an extensive list. There is also add new if you're using some unobtainium that you found on the street somewhere. So make sure you write it in. Write what grade as well. It's a really good idea to put what grade of material you're using, because it just shows that we have an understanding that you have gone out and found the right grade, you've quoted the right grade, you understand what that process is. Again, quantity, cost in euros. Right, please cost in euros. I don't know why it's in euros, I have absolutely no idea, but please cost in euros. And make sure in your explanation file you've got the exchange rate you used at that time. Put a date, put a time, because it changes rapidly, but make sure you've done it. It doesn't matter what it is. If you do it and the market crashes tomorrow, but you've got the date and time that you've used, doesn't matter. Okay, hasn't got to be super accurate, just you know that you've done it. Okay, so again, look, we've done here is we put materials in. Okay, this is really arduous and you guys are going to hate it by the end of it, but when it's done, it's quite satisfying, I promise. Is material, process, fastener, tooling. Material, process, fastener, tooling. It will take weeks. And we'll, just for a second here, do not start this a week before the submission. You will fail. And I will sit and laugh at you, fail, negative points, bye-bye. Do not do it. Start it now. Get the whiteboard. Don't sit and try and write this now, you've got no chance. But get the research done now. Go and get on a whiteboard and sketch it all out, have a look at it. Do it now, because believe me, a week before, and you've got to put in 18-hour days just to get anywhere close. It's not going to be your best work. Cost, is it 120 points? Please someone correct me if it isn't. I think it is. It also can be negative 120 points. So if you do not put the time into cost and you've got, well, we're only going for acceleration. Cool, the points for acceleration we can deduct from here. Yeah, if you've got, oh, I'm not doing, well, I had a team a couple of years ago. We're not really doing cost, the car's in scrutineering. Cool, how many points are you going to get for doing sprint? This amount, cool, right, that's minus 120. Because you haven't turned up to the event. This is a critical part. Make sure you take it seriously. You do it for design, you do it for business, make sure you take it seriously. I would name and shame that team, but I can't remember who it was. Okay, so again, same thing again, fasteners, put them all in there, tooling, put them all in there. Again, I am just going to witter on and on and on about doing this. Make sure you've done it, make sure you've done it right. So I think the best thing to do at this point, what time is the Red Bull thing? Is it 11 o'clock? Excellent, that leaves us 5 minutes. So, oh come on. What'd you do? Thank you very much. Right, I am around all day. Please come and grab me. I'm happy to sit and chat. Look, watch the videos, watch the support material. Has anyone got any questions before we finish? Please.
When it comes to tooling and stuff, it says in the rules not to include hand tools and stuff like that.
Excellent, then don't use hand tools. But make sure you use the process of hand tool. There's a hand tool section for process. Okay, anyone else?
You kept saying basically include everything. Is there anything that comes to your mind that we shouldn't include?
T-brakes. The more detail you put, the more accurate it's going to be. So do it. So there is going to be certain things that you go, yeah, that's really stupid, don't put that in. So don't put it in, yeah. There's, and I hate to swear, but there's a common sense element. Okay, anyone else? Any questions? All good? Lovely? Right, go and see Red Bull. Oh, go on. You stay behind. Apologies, let me